Okay, so guys, I think that we're ready to start a practice problem at this point, and we'll just do the first one as a worked example because this is like a very hard skill and we're just starting from the beginning, okay? So it says, calculate the difference in Gibbs free energy in kilojoules per mole and kilocalories per mole. So we're going to need both values between the chair conformations for the following cyclohexanes, okay? So the first thing we need to do is we need to draw these cyclohexanes, guys, because we need to know exactly how many A values to use and what's the relationship. As you can see, I have two different substituents. I have iodine and I have alcohol. So I need to know, am I going to be adding these values together because they're both moving into the axial at the same time? Or am I going to be subtracting them from each other because when one goes into the axial, the other one leaves? Okay? So let's go ahead and draw it and I'll show you. So this molecule, this chair would look like this. You can draw any chair you want. I'm just going to draw that I have its trans 4-iota-1 alcohol, basically. So I'm going to put an OH facing down here on the 1. That's my 1. Which means that my iodine must be facing what direction? Should I face it axial or equatorial? Well, for it to be trans, I should face it equatorial. So I'm going to put my iodine there and my alcohol there. Make sense so far? Now, as you notice, the conformation that I just drew has both of them equatorial. That means when I go to flip this thing, what's going to happen? What's going to happen is that now I'm going to get both of them axial. Okay, so that means that in order for this to flip axial, both of them have to flip axial. If both of them are flipping axial, that means it's taking the energy of both of them to put it in that position. So that means I'm going to have to add these A values together because both of them are moving into the axial at the same time. So let's add these up. Iodine has an A value of 1.9 and alcohol has an A value of 4.2. So let's go ahead and add these together. So I've got 4.2 plus 1.9 equals 6.1 kilojoules per mole. Okay, so that's the answer in kilojoules. Now, in order to get the answer in kilocalories, I'm going to have to divide this by the conversion above. So I'm going to take my calculator and I'm going to punch in 6.1 divided by 4.184. And that's going to give me a value in kilocalories of 1.459 kilocalories per mole. Okay? And according to the significant figures, since I only have 2, then that would just turn into 1.5. Okay? Cool. Okay, guys, so I know that you don't really know what this means yet, but now you know that that's the energy of both of them. So that's the A value. I had to add the A value together for it to make sense because I have 2 substituents, not just 1, okay? So now what you guys are going to do is you're going to do the same thing here, but don't just assume that you can turn your brain off because I showed you. You still have to draw the cyclohexane and determine, are you going to add these A values together? Are you going to subtract them? Why would you do one or the other? So go ahead and try to do that, and then I'll answer the question.